Never hurts to get a lot of practice. So in this video, I'm just going to do a bunch more of essentially what we call long division problems. And so if you have 4 goes into 2,292. And I don't know exactly why they call it long division. And we saw this in the last video a little bit. I didn't call it long division then, but I think the reason why is you could think it takes you a long time, or it takes a long piece of your paper, or you kind of, as you go along, you kind of have this thing that this long tail that develops on the problem. So all of those are at least reasons in my head why it's called long division. But we saw in the last video that it's a way to tackle any division problem while just knowing your multiplication tables up to maybe 10 times 10 or 12 times 12. And just as a bit of review, this is the same thing as 2,292 divided by 4. And it's actually the same thing, and you probably haven't seen this notation before, as 2,292 divided by 4. This, and this are all equivalent statements on some level. And as you can see, you say, hey, Sal, that looks like a fraction, in case you have seen fractions already. And that is exactly what it is. It is a fraction. But anyway, I'll just focus on this format. And in future videos, we'll think about other ways to represent division. So let's do this problem. So 4 goes into 2 how many times? It goes into no times. So let's move on to, let me switch colors. So let's move on to the 22. 4 goes into 22 how many times? Let's see, 4 times 5. 4 times 5 is equal to 20. 4 times 6 is equal to 24. So 6 is too much. So 4 goes into 22 5 times. 5 times 4 is 20. There's going to be a little bit of a leftover. And then we subtract. 22 minus 20, well, that's just 2. And then you bring down this 9. And you saw in the last video exactly what this means, right? When you wrote this 5 up here, notice we wrote in the hundreds place. So this is really a 500. But in this video, I'm just going to focus more on the process. And you can think more about what it actually means in terms of where I'm writing the numbers. But I think the process is going to be crystal clear, hopefully, by the end of this video. So we brought down the 9. 4 goes into 29 how many times? See, it goes into at least 6 times. What's 4 times 7? 4 times 7 is 28. So it goes into it at least 7 times. What's 4 times 8? 4 times 8 is 32. So it can't go into it 8 times, so it's going to go into it 7. 4 goes into 29 7 times. 7 times 4 is 28. 29 minus 28, to get our remainder for this step in the problem, is 1. And now we're going to bring down this 2. We're going to bring it down, and you get a 12. 4 goes into 12. That's easy. 4 times 3 is 12. 4 goes into 12 3 times. 3 times 4 is 12. 12 minus 12 is 0. We have no remainder. So 4 goes into 2,292 exactly 573 times. So this 2,292 divided by 4, we can say is equal to 573. Or we could say that this thing right here is equal to 573. Let's do a couple more. Let's do a few more problems. Let me pick a nice, let me do that red color. So say we had 7 going into 6,475. Maybe it's called long division because you write it nice and long up here and you have this line. I don't know. There's multiple reasons why it could be called long division. So you say 7 goes into 6 0 times. So we need to keep moving forward. So 7, so then we go to 64. 7 goes into 64 how many times? Let's see. 7 times 7 is, well, that's way too small. Let me think about it a little bit. Well, 7 times 9 is 63. That's pretty close. And then 7 times 10 is going to be too big. 7 times 10 is 70. So that's too big. So 7 goes into 64 9 times. 9 times 7 is 63. 64 minus 63, to get our remainder at this stage, is 1. Bring down the 7. Bring down the 7. 7 goes into 17 how many times? Well, 7 times 2 is 14. And then 7 times 3 is 21. So 3 is too big. So 7 goes into 17 2 times. 2 times 7 is 14. 17 minus 14 is 3. And now we bring down the 5. We bring down the 5. And 7 goes into 35. That's in our 7 multiplication tables 5 times. 5 times 7 is 35. 5 times 7 is 35. And there you go. And so the remainder is 0. So all the examples I did so far had no remainders. Let's do one that maybe might have a remainder. And to ensure it has a remainder, I'll just make up the problem. It's much easier to make problems that have remainders than the ones that don't have remainders. So let's say I want to divide 3. Let's say I want to divide 3 into, I'm going to divide it into, let's say 1735092. This will be a nice beastly problem. So if we can do this, we can handle everything. So this is 1,735,092. That's what we're dividing 3 into. So 3 goes, and actually I'm not sure if this will have a remainder. And in the future video, I'll show you how to figure out whether something is divisible by 3. Actually, we can do it right now. We just add up all these digits. 1 plus 7 is 8. 8 plus 3 is 11. 11 plus 5 is 16. 16 plus 9 is 25. 25 plus 2 is 27. So actually, this number is divisible by 3. So if you add up all of the digits, you get 27. And then you can add up those digits. 2 plus 7 is 9. So that is divisible by 9. That's a trick that only works for 3. So this number actually is divisible by 3. So let me change it a little bit so it's not divisible by 3. Let me make this into a 1. Now this number will not be divisible by 3. I definitely want a number where I'll end up with a remainder, just so you see what it looks like. So let's do this one. 3 goes into 1 0 times, so we can just move forward. You could write a 0 here and multiply that out, but that just makes it a little bit messy in my head. So we just move 1 to the right. 3 goes into 17 how many times? Well, 3 times 5 is equal to 15. And 3 times 6 is equal to 18, and that's too big. So 3 goes into 17, or right here, 5 times. 5 times 3 is 15, and we subtract. 17 minus 15 is 2. And now we bring down this 3. Set 3 goes into 23 how many times? Well, 3 times 7 is equal to 21. And 3 times 8 is too big. That's equal to 24. So 3 goes into 23 7 times. 7 times. 7 times 3 is 21. And we subtract. 23 minus 21 is 2. Now we bring down the next number. We bring down the 5. I think you can appreciate why it's called long division now. We bring down this 5. 3 goes into 25 how many times? Well, 3 times 8 gets you pretty close, and 3 times 9 is too big. So it goes into it 8 times. 8 times 3 is 24. I'm going to run out of space. You subtract, you get 1. 25 minus 24 is 1. Now we can bring down this 0. You bring down this 0, just like that. And you get 3 goes into 10 how many times? Well, that's easy. It goes into it 3 times. 3 times 3 is 9. That's about as close to 10 as we can get. 3 times 3 is 9. 10 minus 9, I'm going to have to scroll up and down here a little bit. 10 minus 9 is 1. And then we can bring down the next number. I'm running out of colors. I can bring down that 9. 3 goes into 19 how many times? Well, 6 is about as close as we can get. That gets to 18. So 3 times 6. 3 goes into 19 6 times. 6 times 3. Let me scroll down. 6 times 3 is 18. 19 minus 18, we subtracted up here too. 19 minus 18 is 1. And then we're almost done. I can revert back to the pink. We bring down this 1 right there. Bring down that 1. 3 goes into 11 how many times? Well, that's 3 times, because 3 times 4 is too big. It's 3 times 4 is 12, so that's too big. So it goes into 3 times. So 3 goes into 11. 3 times 3 is 9. And then we subtract, and we get a 2. And there's nothing left to bring down, right? And when we look up here, there's nothing left to bring down. So we're done. So we're left with a remainder of 2 after doing this entire problem. So the answer, 3 goes into 1,735,091. It goes into it 578,363, remainder 2. And that remainder 2 is what we got all the way down there. So hopefully you now appreciate that you can tackle pretty much any division problem. And you also, through this exercise, can appreciate why it's called long division.